In this session, we will try to develop an understanding of artificial neural networks. In definition, artificial neural networks are computing systems vaguely inspired by the biological neural networks that constitute human brains. So now let's say hi to Mimi, the 2-year-old kid who is trying to help us understand the concepts of artificial intelligence. So for 2 days, we show Mimi different type of apples and constantly tell her that these objects are called apples. Okay. So on day 3, if we were to ask Mimi that what is this, right? Then there is a high chance or there is a very high probability Mimi would say this is an apple, right? The reason that Mimi is able to say on day 3 that this is an apple is because for 2 days we have trained Mimi's brain to identify apples by giving her input images of so many apples, right? So basically what we have done is we have trained her brain to identify apples. So if we were to zoom into Mimi's brain, right, basically what we have done is that we have trained a neural network in her brain to recognize the object as an apple, and our brains are made up of billions of these small neural networks interconnected with each other, giving us the ability to process billions of data points together at one go. So when we transpose a neural network from a human brain to a computing system, in its simplest format, artificial neural networks have neurons arranged in series of connected layers where there is an input layer, there is an output layer, and there are hidden layers, right? So now if we replace Mimi's brain with an artificial neural network and train this artificial neural network with multiple number of images of apples and tell the system that this is an apple, right? We may be able to create a model which is able to identify a real apple using a smartphone camera. And in case we plan to identify more number of fruits like banana, oranges, and more, then in that case, if we are able to train our artificial neural network with labeled images of bananas, labeled images of apples, and labeled images of oranges, we may be able to develop a system by which it is able to identify bananas, apples, and oranges even there, right? To a neural network, there are two key elements. One, number of neurons, and second, the number of layers. Depending upon the complexity of the problem, we can choose the number of neurons and the number of layers we want for our system. So to understand this better, let's look at a platform developed by Google to visualize how artificial neural network work. This is a tool developed by Google to help people visualize how artificial neural networks work. My purpose to show you this platform is to make you understand the concept of neurons and layers with respect to the complexity of the problem. All right. So let's take a very simple problem. Let's take this problem, right, where we want to identify the area of orange dots and then identify the area of only blue dots. All right. Out here we see there is an input layer with two neurons, and then we see there is an output layer which we call as an hidden layer with four neurons. All right. And what we do is we try to reduce the number of neurons. So this is the input layer and this is the output layer, which we are also taking as one hidden layer, right? So what we do is we run the experiment and see that we are getting good results, right? So we have identified the area of orange dots and then we have also identified the area of blue dots, right? Let's try to even reduce this to one neuron. Great, it is still working out very effectively. All right, the model is converging very fast with even one neuron, because this is a very seems to be a very simple problem. Right, now let's take another a little more complicated problem, where we now want to identify the area of blue spaces and the area of orange spaces. Right, and let's see that with one hidden layer and with one neuron, will it be able to do. Right, so we can see here, right, it is not converging, right? So this area is not coming out to be blue. This is not actually converging. So what? Let me do one thing. Let me add a couple of more neurons here, and let's see how this works. Okay, this is a far better, uh, model convergence that is happening, right? We can safely, but yes, still we see that there is some blue dots outside the blue zone, right? But still, it is a decent output. All right, now let me do one thing. So we have three neurons. Let me add one layer to it with two more neurons, right? So now we have two hidden layers, and we have three neurons here, and we have two neurons here, and let's see, by adding another layer, are we able to get a better result? All right, yes, I think we have improved our result here, right? So with adding one more neuron, what we have been able to do is that we have been able to improve our results. Now let's look at a further more complicated problem like this, right? I try to find that will this model be able to converge and give us the right good results. All right, so when we see here, great, amazing, right? So we can see that it has been able to pick out the blue area, and then it has been able to pick out the orange area, right? Now let's take even a more complicated problem and try to see that can this set of two hidden layers, one input layer and a set of three neurons and five neurons, can give us an output here, right? Let's see if this works. Okay, I don't see this happening, right? Now let me do one thing. Let me add another layer and maybe add a couple of more neurons to all the layers and see what's the result. Okay, it is still trying to converge. So now to solve this complicated problem, what I've done is I have now added 8 neurons and I've added 6 hidden layers, right? Because this seems to be a rather complicated problem, right? And let's now run and see, does the model converge with this also or not, right? So let's see. Yeah, so now we can see that at least the model is still, like, trying to converge. But yes, when we see this thing, right, so it is now orange, 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 orange. It has kind of been able to demarcate these oranges, and then it has been able to demarcate this. So the model seems to be now working, but it has taken me 6 hidden layers and so many number of neurons to solve a complicated problem. So back to the presentation. I now hope you have a better understanding of the concept of neurons and layers. When we talk about deep learning, as per my understanding, artificial neural network is at the heart of it. And today, it is powering the field of computer vision, speech recognition, natural language processing, and many more. Thank you.